Thank you, Kevin. It's great to be here with you all, even if it is virtually. I'm so happy to be joining you from lockdown land here in beautiful downtown Auckland. And as Kevin mentioned, today I'll be talking about baking security in and talking specifically about an AppSec critical path for development teams. And if there's a little bit of time left, we might talk about some of the things that aren't directly on that critical path. So the classic about me slide. I've had a number of past lives. I started out doing simulation development for a US government agency. I spent some time as a university lecturer, did a bunch of Java development, and I moved into application security in 2014. I've been here in Auckland since late 2017, and these days I'm working for a little company called Datacom New Zealand. And I'm in the fairly new application security services team where I work as the software assurance lead. Well, what does that mean? External facing, for our customers, I advise on software assurance. We do some SAM-based maturity assessments. We provide guidance on how teams can improve their maturity. And of course, we give advisory and implementation services on GRC activities. I present a lot of training. We sell tooling, including a number of the tools that Francesco was talking about in his talk just before the break. And we also do a lot of DevSecOps adoption advisory. Internal facing, we're trying to get all of the development teams doing project work at Datacom to eat our own dog food and have the same level of maturity and the same set of practices in the things that we do for others under contract. And of course, the usual plug, our team is growing, not very quickly. Actually, a quick welcome to Kevin, who joined our team just a couple months ago. And we had another member join just 2 weeks ago. So we are still growing and we are looking for those right fits. If you're interested, give us a shout. I should also mention that at Datacom, a number of other teams are growing even faster than we are. So there are development roles and cybersecurity, SIEM, SOC kind of roles available. If you have interested in that, you can also give one of us a shout and we can get you in touch with the right people. In my other job, I do a few things for OWASP. Within the OWASP New Zealand Chapter, I run the Auckland meetup. If you're interested, our next session is next Tuesday evening. And of course, since we're still in lockdown, it will be online via Zoom. So you can go ahead and sign up for the meetup and join us for the Zoom meeting. A couple years ago, I started the OWASP New Zealand Chapter's Training Day events. We've had a couple of those. Last year, we managed to squeeze a training day in Auckland as well as Wellington in between lockdowns. Hopefully we'll be back and even bigger in 2022. I ended up giving up this year that we just couldn't find a date that we weren't locked down. The security.ac.nz student conference, which was originated by Kirk Jackson, hopefully again will come back from our break next year. We have dates in August in Auckland, and Kirk will be working on dates in Wellington. So keep those things on your calendar. Hope to see you there. And then, of course, I have to promote the OWASP New Zealand Day conference. I've been here, as I mentioned, since the very end of 2017. I attended my first New Zealand Day in February of 2018, where I was a casual volunteer. At that event, I said, I'd be happy to help out, happy to take a slightly more active role in next year's conference. So I became the conference chair, and I've been chairing the event since then. We are scheduled to hold the next OWASP New Zealand Day during our regular mid-February dates, with a COVID contingency of bumping to July. This year we're going to be at the Auckland University of Technology, the city campus, just up the road from our usual haunt at the Owen Glen building. I want to point out that both the call for presenters and call for training are currently open, and we've still got some sponsorships available. So now, the reason I'm here, and what I want to talk to you about. It's all about software assurance. Let's start with a lovely dictionary definition. What is software assurance? It's around the level of confidence that all of the stakeholders have that software being delivered and used is free from vulnerabilities, whether they're built in or they came about accidentally, and that the software functions the way we intend it to. Now, to parse that definition a little bit, it's really about these three things. We want to have that stakeholder confidence that what we're delivering are the features that we intended to deliver and nothing else. We want to prevent, detect, and remove vulnerabilities in the applications and in their supporting infrastructure. And we want to improve the reliability and resilience of our production systems. A key thing here is that software assurance is so much more than doing a penetration test at the 11th hour. As many of you have experienced, if you do a penetration test as your security check, it's very often scheduled for a 1 or 2 week window, just a couple weeks before the go live that marketing has already promised. It doesn't really matter what you find because go live isn't being rescheduled. We want to get out of that mindset. We want to get to the point where we're producing reliable, resilient, secure software from the beginning, that shift left mentality. And when we do those penetration tests, as was mentioned in an earlier talk, we've addressed all of the low-hanging fruit. And then if we do have the penetration testers find something interesting and difficult to find, that challenging vulnerabilities, then we can have some real conversations about whether or not there's sufficient risk to delay go live. Now, a framework for talking about this. The OWASP SAM, Software Assurance Maturity Model. This is an open framework, and it provides an effective way for organizations to think about whether or not they're doing the right sorts of things around application security. So this is a model for the organization's practices. It's not about going and testing an individual application to see if it has XSS or CSRF vulnerabilities. It's about those overall practices and the environment in which software is being produced in order to produce that clean, secure software. I glossed over this a little bit. I've been a little involved in SAM. I started working as a core team member in 2018. I am a co-author of the current version of the model, and as I mentioned on the About My Work slide, I'm also out doing SAM assessments for customers. And you would correctly conclude from all of that I think this is pretty important stuff, and there's really a lot there for us. The SAM model has 15 practice areas across 5 business functions or domains. Now, all of these are important. It's important that we have an application security strategy, that we're collecting metrics in order to understand how well things are working and where we need to improve. It's important that we have policies for teams to follow and that we understand all of our compliance requirements, such as NZISM and Privacy 2020, GDPR if it's applicable, Australian rules if we're also working across the ditch. It's important that we have training in place. It's important that we think about architectures. But many of these, if you really look at them, they're kind of enterprise level. As a development team trying to get code written, we don't spend time writing the company's AppSec policy. We just need to understand and follow it. So that leads to the fact that for development teams, there are really 6 of these practices that form the core of what they can impact. and how a development team, even without the senior level buy-in and all of the funding that you need for a lot of these other practices, you can start doing things next sprint to make your security better. And if you look, they form something of a path that you could look at these activities more or less as following from one another. And this is what I consider the critical path for developers in application security. Now I'm going to talk about each of these activities, the activities within each of these practices for a couple minutes each, focusing on a couple of them a little bit more, and then how this reaches the end of your process with some new artifacts and new information that can be used by decision makers. So first, threat assessment. I should have mentioned, running ahead of myself a little bit, that in each of the SAM practices, there are 2 activity streams, and then there are 3 broad categories of activities called out in each stream. So within the threat assessment practice, the 2 streams are application risk profiles and threat modeling. Now, application risk profiles is the idea that we have looked at the risk to the business of an application, and in particular, it's the impacts. So we look at the confidentiality, integrity, and availability impacts of a breach or disablement of the application in order to understand how important that application is to keeping the lights on in the business. In order to understand that and to be able to look at applications relative to one another, we use a standard instrument. The most common form of this is an application risk profile questionnaire, which can be anywhere from just a few questions to, I think the longest I had to fill out was about 100, where they wanted supporting artifacts and other documentation as well. But whatever the right number of questions is, in order for you to understand things like, how big is the user community? Is this a public-facing or completely internal application? What sort of personal data are you collecting or managing? What regulatory requirements do you have around protection of data within the system or auditability of transactions? To understand all of those things in order to figure out, well, how important is this system and what sort of risk does it pose that we're deploying it? These things in isolation, looking at one application and giving it a number, say it's 88 out of 100, that's not nearly as useful as being able to say, for the 60 applications that we manage within our portfolio, we've got 3 that are 85 to 100, and then the bulk of our applications are really around a 70 risk, and then we've got some that basically brochureware that are down in the 30s or 40s. And when you look at things that way, you can sort of easily pick out, well, here are our crown jewels. These are the things that we want to spend a lot of time protecting. And these other ones, the risk is much more moderate, so we're going to invest in those, but not as much as in those high impact systems. In threat modeling, the key thing is to make sure that we have a consistent, repeatable technique, and it needs to be self-service. Development teams need to be able to do their own threat modeling because organizations are never going to hire enough AppSec specialists to have the AppSec team do it for them. I also don't believe that's a great idea, but it's important to realize you need to select a methodology that the teams can do themselves with some instruction, some guidance, and some facilitation from those experts like me. So the methodology that I recommend is one you've seen before, of course with my own personal twist, which I call DiLeo's 7 questions. Now this is adapted from the 4 questions approach that Adam Shostak talks about, where really all I've done is expand some of the questions into multiple parts because I think that they're important enough to address separately. So the first question is, what are we building? Most commonly, the way that we represent what we're building is to draw a data flow diagram, because threats most often follow the data. We want to know what are the data being processed, where do they get stored, how are they passed from one process to another, what users interact with them, and what are our sources and sinks for the information. Then we ask the question, what can go wrong? Now, you can use just about any method you want to identify threats, but the one that I tend to favor is to use STRIDE as a prompt to help teams understand and identify what the things they need to be concerned about are. And of course, I think it was mentioned in an earlier talk, STRIDE it's a mnemonic to help you think about some general categories of threats: spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. So you go through the STRIDE analysis looking at the elements of your system to say, what could go wrong here? What could go wrong here? What could go wrong here? And you do that until everyone's tired of it, and or you've done a fairly thorough job of identifying those threats. So these would be things like impersonating an administrator or modifying a request in transit, man-in-the-middle kind of attacks. As you capture those, then you ask the question, what could we do about it? Now, this is a point where I've split the question out a little, because first I would like for teams to think about all of the different ways they could mitigate the problem. A particular one that comes up a lot is as we start talking about authorization abuses, development teams might come to their own realization that this existing system doesn't have a great authorization model, and we really should re-engineer that. So they'll bring it up and they say, well, we could fix the authorization model, centralize this, make sure things are fully mediated. But then reality sets in when you ask the question, what are we going to do about it? Then this is where budgets and priorities and timelines come into play. And very often, the one best thing that everyone agrees they should do is just not going to happen this fiscal year. At which point you then talk about what else could we do, compensating controls, additional safeguards we could put in place. Once you decide what you are going to do about it, then you look at risk and you ask the question, now that we've selected these particular mitigations to do, are we leaving any risk on the table? And if we are, then we need to ask the business owner if they're willing to accept that residual risk. And if the answer is no, then we go back to step 4 and change our decisions. If they're not willing to accept the residual risk that's left after we've selected some mitigations, that means they want more. So let's figure out what else to do. After you finish going through that cycle as many times as you need to, you've now got a set of mitigations. And these are things you're going to do, which we generally think of as requirements, which then means we can test them. So coming out as a consequence of this, we've identified some threats, we've realized some places where we need to change what we're doing, we capture those as requirements for the software, and then we figure out what our test plan will be to show that we've successfully implemented those new requirements. See, nothing to it. And then the last question is our model correct? When you get to the end of all of this, and you've been working off in model land, representing the system and making all of these decisions, is that actually what the developers built? Or does your model represent what they thought they were going to build, and now you need to account for that diversion by going back and updating the model? Representing the same idea in a lovely animated flowchart, you think about the fact that you have an existing system where you've been doing things without specifically threat modeling. Now all we're going to do is impose interpose a threat model into this process by saying we're going to take our existing architecture, what we know the functional requirements are, both for the existing system and for the new things we're planning to do, and we're going to model that. So we build our to-be design as a DFD. We then go through that process of what can go wrong, identifying the threats. We then have that brainstorming session to say, well, what could we do? Then we allow our drivers, these might be compliance drivers, policies we have to meet, budgetary and time constraints, and so on, in order to neck down those things we could do to the mitigations we've selected. And then we capture any risk-based decisions around things we're not going to do. We take from those selected mitigations consequential requirements, and then we feed those into our test cases and our post-deployment checklists. See, simple. As far as how much work that is to do, your mileage will vary, but this can end up adding a few story points to every sprint if you're doing it in an agile environment. Now, looking at some of the other activities, the other practices that I brought up there. So we've got security requirements. We want to incorporate those consequential requirements, those yes and, into our backlog, link those to the features that depend on them to make sure that the definition of done for the feature includes these consequential things are also done. A classic example of this one, which comes up way too often, is file upload. When the business owner says, we need to let customers upload files, instead of having security be the department of no and saying, you are absolutely not turning on file upload, instead we say, okay, what exactly do you need to let them upload? And we can start adding on some requirements to make file uploads less insecure, like restricting file types and adding virus checks and adding signature checks, looking at active monitoring in the data stores, in order to make that as secure as possible while meeting the actual business need. On the supplier side, the other stream of security requirements, this is where we make sure that we're requiring our vendors who are doing bespoke software for us to follow the same standards that we expect of ourselves. That is captured in our contracts through SLAs, especially SLAs on remediating vulnerabilities in their software, so that we can meet our requirements. The next practice, requirements-driven testing, well, this goes back to what I was talking about before of, well, let's make sure we test things. That our QA and regression test cases should include tests for functional security requirements, that we should have verification checklists or scripts for those non-functional requirements, like making sure that we've disabled weak cipher suites on all of our internet-facing endpoints, making sure that the identity provider that we're using is not using a known insecure hash, checking those things off to make sure that what we're delivering and ready to put into production is doing all the things right. In the second stream, this is where we get more active in our testing. We're using fuzz testing to look for susceptibilities to input corruption, adding specific abuse cases to our QA and regression testing, and then also looking at security stress testing or denial of service resilience testing. In the secure build practice, the biggest one is automated repeatable builds that can't be tampered with. So we're trying to make sure the build process itself is secured, and then we want to add security testing into the build pipelines. On technology management, the key element there is software composition analysis, looking out for outdated or vulnerable component libraries that are being brought into our applications. So we want to have an SCA tool in place, OWASP dependency check, or one of the many paid tools that Datacom would be happy to sell you. On the secure deployment practice, same thing. We're looking for automation and repeatable deployments. We want deployment processes that cannot be tampered with. And we want to look at managing environment promotions so that we've got some separation of duties around preventing someone who tampered with code from being able to put that directly into production without some review and a second party approval. On secret management, we want to protect our production secrets, make sure that we're refreshing them with an appropriate life cycle, and that we're not ever storing secrets in source code or committing them somewhere that they can be captured, making sure that developers don't have access to production secrets, and in general, we're doing what we can to protect access. Security testing, this is where our automated tooling comes into play. So static application security testing, dynamic application security testing, and again, dependency analysis, all of which, as I mentioned, Datacom would be happy to sell to you, as well as the fact that there are some other useful free tools out there, including several from OWASP projects. On penetration testing, I know a number of the other sponsors here are very much in the penetration testing arena. We've heard a couple of talks today about how to make that better. And in fact, as part of our advisory services, we will talk to people, including Datacom development teams, about getting rid of those low-hanging fruit before we turn it over to the real pros and have that serious test done. On the artifact side, what does this actually produce as additional stuff? Well, the application risk profiles activities, you're going to get these application risk impact ratings. You're going to put those into a dashboard somewhere so that people can be looking at it and making sure that the senior managers can use that information when they're prioritizing what activities are we going to do for each of our major systems. Obviously, you're going to be creating threat models. Now, these threat models can start out pretty small. You can use a free tool like OWASP Threat Dragon, or you could just do stuff in Confluence pages. I've done that in previous jobs. There are also some very, very, very not free commercial tools that do as good a job as Threat Dragon or the Microsoft Threat Modeling tool. But you get in there, you build those models. A key element about this is that this is not a one and done activity, so threat models are going to grow and change as the system does. You're going to have these new security test cases. Each of your consequential requirements and your non-functional requirements is going to give you test cases for QA to complete, as well as some post-deployment checklists to follow and make sure that your deployed system is meeting all of those expectations. And then finally, in those cases where you've decided that you're not going to do everything you might do, well, you're going to have some risk acceptances. You want to make sure that you've gotten a formal, it could be as simple as an email, but a real affirmative acceptance from the business owner that they're happy with the choices you made. One of the things that I harp on a lot, and this goes back to my first days in a security office, is that you want to get out of a situation and prevent those situations where the development team is implicitly accepting risk on behalf of the system owner. Whenever you make a decision not to patch or not to implement a security feature, you are accepting risk. But it's not your risk, it's the owner's risk. So talk to them about it. Make sure they understand it and make sure they're happy with it. I understand I've got about 3 minutes left, so that means I can talk about one or two practices that aren't on the critical path. And I've got these ordered roughly in order of increasing distance from the teams that have hands-on keyboard. So the first one is education. As a trainer, I love for people to get lots of training. It gives me something to do, it keeps my bills paid. But the key thing here is to make sure that people are getting the right training at the right times, and then giving them an ability to do some continual learning, giving them access to things like CTF platforms or online training resources such as Secure Stack Academy, or Secure Flag, or Secure Code Warrior, or any of the training modules that come with some of the static analysis tools, having that available to them so that when they're running into an issue or they get a warning about something not being a best practice, they can go and watch a 3-minute video and try a lab exercise so that they then understand it. And I meant Safe Stack Academy, not Secure Stack. On the security culture, you have a security champions program. Whatever you might call it, security champions as a name is sort of falling out of favor, but it's the idea of having someone in every development team that everyone knows they can turn to, and then that person knows that they can then reach back to your software security group to answer the hard questions. You want to have that security culture where the things we build are secure by design, secure by default, and secure in deployment. And the last one I'll talk about today is, in the operational management practice, data protection. One of the key things around this is to understand what data you have, where they live, what's your authoritative system, where do you have replicas that need to be synced, to have a data protection policy that talks about classification levels and mandatory protections on storage and handling, have some compliance monitoring to make sure that things like spreadsheets that contain all of your production secrets are not leaving the business through email. So data loss protection policies and possibly some technical controls around that. On system decommissioning, the main thing is, if you're not using it anymore, turn it off. If you're using third-party software like operating systems and platforms, keep up to date, pay attention to when they're end-of-lifing, and think about what you're going to do next. If you're delivering software, do the same thing. Manage your customers to keep them from living on long out-of-date versions. Get them off of the N-4 version so you can stop supporting it. Now, I could talk about all of the other practices if only there were time, but I'm going to stop there now, and thank you all for your time and attention.